Action.
So we have been talking about mass, acceleration, and forces, but can anybody tell me your idea about weight?
Having an object with more force, you have to insert onto it for it to move.
Yeah,
What's the gravity on the mass of an object?
the force of gravity. Okay. Anybody else? Okay. So when you go to a bathroom scale, right? You look down and you see your weight there, right? All right. So that is the gravity that is acting on you. So let's make a little drawing here. And here I have my scale. And so that's gravity, it's right there, okay? So now let's think about, so this is the force on the scale, is mg. Now let's think about a different problem now. Let's say we are in an elevator, okay? Let's say we are in an elevator now, and I have this situation here, and I have my scale here too, and I'm sitting on top of the scale. So what do you think is going to happen? The elevator is moving. What do you think is going to happen to the scale? Yes.
If the elevator like goes from stop to start going up, then your weight's gonna go up. Well, not your actual, but like the scale's gonna say that your weight went up.
Okay. So if the elevator is, let's say the elevator is moving already, okay? It's not a stop or, let's not complicate, make it too difficult. Let's just say it's moving. What happens? Do you have any idea? What? Yes.
The tension on top could cancel your weight.
Tension?
That's why you're kind of moving up.
Okay, so anybody else? Yes.
The pulling of the elevator up is greater than your force exerted down, that's why you're moving up.
Okay, so I'm going to be more specific. If the elevator is going at a constant speed, what is the reading that you think you're going to have? Is the reading going to be higher? Is it going to be less? Or is it going to be the same? And why?
The scale your weight.
Let's think about the first law of Newton, right? What was the first law of Newton?
Object at rest stays at rest, if an object in motion stays in motion.
But there is something also, there is no external force acting on it, right? If there is no force acting on it, the object will stay at rest and will keep moving. You have to remember that. That's, Now here I'm saying the elevator is moving at a constant speed, going up. So what do you expect to be the reading on your scale?
It would be the same.
The same, right? Why? Because it's just the gravity there, right? It's just because there is no other force. If it's being accelerated, then it's a different story, right? Now, do you understand that? If it is accelerated, the scale is going to have a different reading. Now, if it's going up, it's being accelerated up, what do you think is going to happen? Now, let's say now, if it's being accelerated up, and let's say going up is positive, okay? And here I have the force of Earth, right? On this man.
have tension on top.
Okay, so this thing is, if this thing is going up, it's being accelerated, we're gonna have here a reading on the scale. This is the force of the scale on this man. So, according to the second law of Newton, right? We're gonna have that this force, if it's being accelerated up, this force has to be larger than this one, okay? Otherwise, it wouldn't be accelerating. So F of S has to be greater than mg. So F of S, M minus mg is going to be ma. And the A is this acceleration here. Okay. It's the sum of the forces. Remember, if the object is in equilibrium, the net force is equal to what? 0, right? The sum of the forces is 0. If this was going at a constant speed, this here would be 0, right? And the sum of the forces would be 0. So the scale, the reading of the scale would be exactly mg. Is that going too fast, or is that okay? Are you following me? All right. So let's do some, so what's happening here? What's happening here? So if I do the calculation now, my reading on Fs is going to be, I move this to the other side, it's going to be mg plus ma. So F of S is going to be mg plus a. So what is the reading? If the elevator is being accelerated up, what is the reading that I'm going to have there? Higher, right? So I'm gaining weight. I'm gaining weight. Okay? So let's do now the opposite situation, where now the elevator is going down. Okay? Being accelerated, going down. So let's see what's going to happen. Well, if it's going down, I'm going to make another drawing here. Now, acceleration is going down. So, in order to go down, mg has to be larger than the Fs, right? Is that okay? So mg minus Fs is going to give me ma, where a is this acceleration here. All right? So when I calculate this, Fs is the reading on the scale, is going to be mg minus ma. And Fs is going to be mg minus a. So what's happening on the scale? What's happening with my weight? I'm losing weight. You see? I just found a way to lose weight very quick, okay? Just get into an accelerated down with the elevator. So, and then you lose weight very quick, okay? Now, a different problem. Now, if I have here, instead of a scale, if I have now a string, and with some gauge here to measure, so this is going to be, on the string, we talk forces as tension, right? It's the tension on the string. So what's going to happen if I have here, I'm hanging now here, this is me, right? And I have, if I'm not moving at all, what is the value of this tension? Huh? 0? Oh, I'm hanging here by the neck, okay? By the neck like this, right? Huh? Equals to, so it's mg, right? This is mg. And d has to be equal to mg, right?
Yeah.
It's not moving. So the forces, when you add the forces, it's going to be equal to 0. So that means T is equal to mg. Okay? This is not moving, or if I'm at a constant speed going up somehow, right? This thing is pulling me at a constant speed, so it's still my weight. But if it start being accelerated, what's going to happen? Accelerated going up, so it's going to make it even tighter, right? So if it goes up, it's the same as this. And if I'm going down, if this thing is moving down, being accelerated, then I'm going to have some relief here, right? In my neck, because I'm losing weight, so it's not going to be as tight. Remember that, you know. I hate that, professor, so I want to go up, you know, faster, right? Or if you like me, you want to relieve my pain, you just accelerate it down. Okay, is that okay? All right. So let's see another problem now. Let's say I have here him, and here I have a mass. This is M1, and this is M2. Now, let's assume M2 is greater than M1. Okay? So what is, we're going to have a tension here and another tension here. Can anybody tell me what you think the values of that tension should be? Are they different, or?
I think they might be different if one is heavier.
Depending on the
D
weight.
is different? Equal, right? It's the same string, right? It's the same string. Has to be equal. This has to be equal to that. It's like an extension here. Just because it curved there, it doesn't mean anything. So let's look at M1. Because M2 is greater than M1, this thing is going to move that way, right? So it's going to be accelerated up. So let's say up is positive. So what's going to happen? So I have here T is going to be equal minus M1G is going to be equal to M1A. Okay, because this is moving up, it's being accelerated, right? So T has to be greater than M1G. Okay? So this is looking at mass 1. Now let's look at mass 2. And when we look at mass 2, let's say the positive is going down. So if it's going down, mg, m2g minus d is going to be equal to m2a. Okay? So let's do this. So if this is my point object, right? So T is going to be larger than M1G. This is my force diagram, okay? In this case here, this is point 1. In this case, point 2. So M2G is gonna be greater than. All right? Now, we know t is equal to t, right? So I can solve it for t here, solve it for t here, and make this equal, right? So t is going to be m2 a plus g from here, and from here I'm going to have d equals m1 okay? So t moves to the other side, becomes positive. This comes to this side, becomes negative, okay? And here, m1 goes to the other side, becomes positive. You have here g plus a, and here you have g minus a. So when I make this equal to that, so let's see if I can calculate a. So let's do that here. So I have m1 g plus a equals m2 g minus a. So if I multiply m1g plus m1a equals m2g minus m2a. I want to calculate a, so I'm going to bring a together here, this with that one. So I'm going to have here m1a plus m2a, and this guy goes to the other side. I'm going to have m1g plus m2g. Apply distributive property here. I remove a. A is going to be m1 plus m2. Same I do here. G is m1 minus. What is that? Is that correct? This one, m1 is minus, right? Here goes here minus. So it's going to be m2 minus m1. This guy, when this guy goes to the other side, it becomes negative, okay? So that makes m2 minus m1. So a is going to be m2 minus m1, m1 plus m2. So that's one formula. We can also calculate t if we solve it for t. So now that I have this guy, I can plug in that here and make calculation for t. And when I do that, I'm going to get t is going to be equal to 2m1 m2 divided by m1 plus m2, okay? Now, let's look at certain interesting situations. Let's say if m1, let's focus on these two equations now, and let's say if m1 is equal to m2, what do you think is going to happen? If m1 is equal to m2,
Would the acceleration be 0?
acceleration is going to be 0, right? So in this case here, if I have m1 equal to m2, it's not going to move, right? Or it's going to move at a constant speed. Yes.
So you're supposed to multiply the acceleration by g, because I think you're missing it. Right?
Oh, g here. Yes. Sorry. But still, if m1 is equal to m2, this is going to be 0. Acceleration is going to be 0. So this here is not going to be accelerated. It's either going to stay rest, or it's gonna be moving at a constant speed. Okay? Now, another situation is, let's say M2 is very, very large in respect to M1. So M1 is almost zero. What do you think is gonna happen now?
Disregard.
Huh? Is it going to be accelerated up? If M2 is very large, so M1 is zero, what's gonna happen if you plug in those values?
Acceleration will be 0 at some point.
Acceleration, no, if M2 is equal to M1, that's zero. What is it?
Just be gravity.
Just gravity, right? And that makes sense, isn't it? If M1 is equal to M2, well, this is, you know, it's not moving, it's not going anywhere, there's no acceleration, there's no reason to go that way or the other way. But if M1 becomes zero, it's like this guy here suddenly disappears, right? It goes away. And what's gonna happen? The acceleration is gonna be G, like free fall. It's like cutting here, this string. And this thing is just gonna fall, it's just G. Is that okay? And if, now at the elevator then, let's go back to the elevator situation. If I have here my scale, and I'm here, and I cut this cable, what's gonna happen?
Free fall.
It's gonna be free fall. And what is the reading on my scale?
Yeah.
Huh?
0.
Zero, exactly. It's a situation of weightless, right? Weightless. I completely lost my weight. So I'm free, it's a free fall. So I want to do an experiment with this bottle here. I'd like somebody to record me, and I'd like to post that. Okay, can you do, remember you did similar with the monkey, but now it's Eugene, so so I try to look at what happens to the bottle, bottle here, okay? So what do you think is gonna happen?
It's gonna stay.
The ball is gonna stay?
What was the question again? I'm sorry.
If I'm jumping here,
Oh.
holding this ball has some weight. It's really painful to keep holding this thing like that, you know? It's very heavy, you know? It's putting some stress on my muscles. So when I jump, what do you think is gonna happen?
The water's gonna go up first.
The water goes up,
Yeah.
It's gonna weigh less relatively for a short while.
weight less, yes.
When you first jump, the water's gonna come down, but as you calm down, the water will stay up.
The water is gonna stay?
No, the water will, the water will work in the opposite force you're going in. So if you're jumping up,
Yeah.
the water will go down.
I'm gonna try not to jump up, you know, I'm gonna try just to walk and just fall, okay? If I'm just falling, we just talked about that on the scale, right, on the elevator. What was the reading? 0, right? So it's weightless. So I'm gonna try to bring my hands up as I'm falling, just to show that the ball is falling, free, weightless, right? So I don't have to hold the ball anymore. So can try to, I think you need to go a little further, too close, and then try to focus on the ball. We'll do a couple of times to see if it works. I hope this is the first time I'm doing this, you know, I'm a little, you know, nervous, so. Okay, so, what was that? Let's try again. Oh, I push it up. I don't want to do that, right? I just want to walk a little bit. Let's see if we get the good, every time I jump, do a new one, because otherwise it's
The
gonna
one
be.
inside.
Did I do that? Yeah, I just wanted the good one, you know, I'm gonna post it on campus, so you guys see it at slow motion. So, I don't know if it worked, but the idea is that, you know, now, let's talk a little bit about, what is my weight when I'm falling, when I touch that ground, what do you think is happening? How much am I feeling, you know, in terms of weight, because,
More than your weight?
huh?
More than just your weight?
More than just my weight. Can we try to figure out how much that is?
It's your mass times gravity, right?
Yeah, so let's do some calculations, okay? First, let's do this. Let's calculate how much time it takes me to get down, okay? How much time do you think it's taking me to get down? Let's do some measurements here. So I measured, like half a meter. So the height is half a meter, so it's 0.5 meters, okay? Which formula are we going to use? We can use that delta y equals 1 m g t squared, okay? So let's do some approximation. Let's say g, we know g is 9.8 meters, per square seconds, but let's do that approximate to 10 to make it easier. So this is going to be 0.5 equals 1 times 10 t squared. So this is going to make what? This is going to be 5. So it's going to be 0.1 t squared. So t square root of 0.1 is, let's see, we have my calculator here. Point 1, 0.3, 2 seconds. So this is the time it's taking me to reach the ground, okay? Now, what's going to be my speed, right? What's going to be my speed when I hit the ground? What is the formula that I'm going to use?
Velocity initial times time.
Yeah, so the final initial GT, like that. Is that okay? So, the initial is what? What is the value of the initial? I'm on the top of the chair. 0, right? The initial velocity is 0 because I'm standing here, I'm not moving, I just step a little forward. So this is 0. So V is going to be G, let's assume it's 10 again, but now I have my time, the time is 0.32, so V final, when I'm hitting the ground, is going to 3.2 meters per second. So that is my speed. Now, assuming that moment I stop is like 0.2 seconds, okay? Just that, because now we need to calculate the acceleration to stop me right there, right? So we can now use that V. The V final is going to be 0, right? So to stop, to make me stop there now, let's calculate what is that acceleration here, okay? And having this acceleration, I can calculate my extra weight, right? So let's do this. So let's assume this is like, let's say, 0.15 seconds, right? It's really short, I just put it like this, right? My initial speed is 3,
But we just found time.
huh?
We just found time.
Time?
Yeah.
Oh, this
Yeah.
here is the time for me to jump from here to there. Okay, that was the time for me to reach the ground. Now, once I reached the ground, I was decelerating, right? I had some speed. I arrived at the ground with this speed, and suddenly went to 0, right?
Yeah.
So this is the final speed of the fall is the initial speed that start me to stop, okay? So the final is 0 because I stopped. I'm trying to calculate that acceleration so I can figure out what kind of fuel I have in terms of my weight coming down, right? My weight has increased because I'm being accelerated, right?
Mm-hmm.
So what's going to be this? So it's going to be 3.2 divided by 0.15. That's going to be my A.
Wait, Professor, where do we get the 0.15 from?
He just subtracted.
I just, I'm assuming,
Okay.
guessing, right?
Sure.
So the time to come down
Yeah.
was 0.32, so I'm assuming about half of it, to stop, Maybe, it could be less, maybe just 0.1, but this is just,
Sure.
So how much is this gonna be?
21.2. I mean,
21?
21.3 miles per second square.
So that's my acceleration, right? So let's now figure how much is going to be. This is how much I'm gaining weight. Right? I'm gaining this weight, right? And how much that's going to be in terms of this is like like 2.1 G. Right? So A is like 2.1 G, because G is 10, right? So I can write this in terms of G now. So F is going to be M A plus G, but A is 2.1 G plus G, that makes 3.1 G. M. Okay, so my weight has increased by 3 times. So I'm 100, let's say 150 to make it easy. So it's like equivalent to what? 450, right? It's like 450. I increased my weight and I have the feel of a 450 reaching the ground. All right. Okay, so